actually of sodium hydroxide by dissolving an unknown mass of the pellets in 250 cm cube of water. 25 cm cube of the solution is titrated against a standard solution of hydrochloric acid. Now, what is happening is that, remember, we said that you are to be given what is known as a standard solution. Now, a standard solution is what is known. So you know the concentration, and you can either know the volume that you're going to use or determine the volume, but the concentration is given. So with titration, remember that you're working from known to unknown. You're trying to use what you have to determine the information for something else. In this case, we're looking at the reaction between sodium hydroxide and hydrochloric acid. Hydrochloric acid is our standard solution. So we are working now from the information given about sodium hydrochloric acid to determine the information about sodium hydroxide. So the titration was done, and here are the readings. All right. So the first thing that you need to do is to record your readings and determine the volume of the acid used. So let's go. What would be the reading, the initial reading for titration 1? Pretty good. And for others who are not seeing, white is 1.3. Remember that for a burette, we read the scale downwards. All right. So it increases as it goes down. The scale is inverse. All right. Or should I say reversed? Not inverted. Inverted would have been negative values here. So it is reversed. All right. What's the final for titration number 1? 26.4. I remember we write to 2 decimal places. So we have to add the zeros. All right. Titration number 2. What I'm writing? No, I am writing them in the wrong order. So initial goes at the bottom and final goes to the top, just to make calculations easier. All right. So we have 2.10. Excellent. And what's the final? 27.10. We need to calculate. Now we need to calculate the volume that was used for each of the titration. All right. We don't even need calculators for this. Let's go now. So 26.40 minus 1.30. What would we get? Excellent. All right. 27.10 minus 2.10. Good. And the last one is 25.20. All right, beautiful ladies. This is it. Absolutely correct. All right, now it says, what is the average volume of the acid used? Now, if you notice, it's a very simple question, but look at the marks. 4 marks. So it means that you're going to have to show some form of working. How do we show the working for this? Adding all of them. And then we're dividing it by 3. Let me put 25.10. Yes, that sounds just about correct. I will need to write our unit. Please don't forget your unit, ladies. Centimeters cube. All right, now write a balance equation for the reaction. What were the reactants? So sodium hydroxide plus, nice, HCl, hydrochloric acid. What is going to be produced? Sodium chloride and water. Now, you know our equations are not complete unless we put in our state symbols. We need to add any coefficients to this one? But we actually don't. We get down to the meat of the matter, ladies, the analyzing part. What can we analyze about this? So when we calculated this, ladies, the 25.1 cm cubes, what this means is that 25.1 cm cubes of the acid were required to fully neutralize 25 cm cubes of the base. That is the understanding from it. So remember, we said that we wanted to know what was the exact volume for your reactant. So 25.1 cm cube is required of the acid to neutralize 25.0 centimeters cube of your base. Now, the volume that is used is highly dependent on the concentration. So right now, we know the concentration of our acid. We need to find the concentration of our base, because remember, the higher the concentration is, the more reactive that the substance is. The less concentrated is this, the more volume pretty much you're going to be required. The more concentrated, the less volume you're going to be required. So that's something that you have to have in the back of your mind. Now it says calculate the number of moles of hydrochloric acid used in the titration. All right, now how do we find number of moles? So we're going to do it two ways. We're going to do it for the persons who like the formula, and we're going to do it for the persons for reasoning. How do we find the number of moles? Concentration times volume. Now, is it just volume, or we have to put it in a certain
DM cube.
volume in dm cube? Excellent. All right, so let's go. What's our concentration of our acid? It is 0.05, and we are multiplying that by the volume of the acid. So we have to be mindful of that, ladies. The volume of the acid is what we found from our table here. All right, so we have to be mindful. And then this is what we need to now convert into decimeters cube. How do we do that? Take this figure and divide it by 1000 to convert to decimeters cube. 0.0251. And remember, ladies, you can do this without a calculator. Yes, I know you're going to have access to your calculator, but remember, punching in numbers, it takes time. So all you have to do, my decimal is right here, decimal point is right here, and I'm moving 3 spaces. 1, 2, 3, and I put the placeholder there. So sometimes you can do this without a calculator. All right, awesome. Now let's go. What would my answer be? 0.001255, and this is moles. All right, now let's go to persons who are more of the reasoning type. All right, so this is what we know. From the concentration given in the acid, which is 0.05 moles per dm cube, right? Moles per dm cube tells us how much is there per dm cube, per 1 dm cube. So I know that 0.05 moles were dissolved in 1 dm cube. I also know that 1 dm cube is 1000 cm cube. So I can make my units the same by saying that 0.05 moles are in 1000 cm cube. How much is in 25.1 cm cube? That's what they're asking us, you know. So your concentration tells us how much is in 1000 cm cube. What would be the number of moles if I only used 25.1 cm cube out of it? All right, and we're going to do the little trick that math taught us. We're going to cross multiply. All right, now when we cross multiply, it brings us to our question mark, which is the moles, is equal to 0.05 times 25.1 all over 1000. And you should get the same answer. All right, now the question now is, now that we have all the information for the acid, we have the concentration, we have the volume, and we have the number of moles. We need to now move on from the known to the unknown, which is the base in this case. So the number of moles of sodium hydroxide in 225 cm cubes of the solution. How do we find the number of moles? Now, there's something that is suggested that we use. What do we use to find the number of moles? We're going to use the mole ratio to find the number of moles for the base. Now, the mole ratio comes from this equation here. All right. Now, we are looking at the mole ratio between the acid and the base, not the products this time. All right, what's the mole ratio between the acid and the base? What can you say? It's a 1 to 1. Very good. So this mole ratio here is actually a 1 to 1. What does a 1 to 1 mole ratio mean? Since the mole ratio is 1 to 1, then moles for sodium hydroxide is equal. We have just two more questions left, ladies. The number of moles of sodium hydroxide in 250 cm cube of solution. So that's what they're asking you to solve. What's the number of moles of sodium hydroxide in 250 cm cube of solution? So notice, ladies, you're now asked for the number of moles. Now, usually you're asked for what's the mole concentration. Now, even though your mole concentration would tell you the number of moles dissolved in 1,000 cm cube, all they want for you is to reason out the number of moles. And I'm using the word reason out. All right. So remember, I told you that although your formula brings to you a quick solution because you're just plugging in A and B and either multiplying, dividing, or adding, whatever the case is. I also told you that there are sometimes, based on how they ask the question, it will be best suited for you to reason out the answer and not necessarily apply a formula. All right. So in a case like this, there are two ways of reasoning it. And I'm wondering if anyone sees. Look at question 4 and look at question 5. I'm going to help you by highlighting. I'm going to highlight. The value is just 10 times the amount. That is what it is. So we found it for 25 cm cube, but they're now asking us for 250. So common sense would tell you that 250 is 10 times the amount. So how would you find the number of moles for 250? So 250 is 10 times. So it's 10 times the volume. So all you have to do is just use a value 0.01255 times 10. That's all we have to do. And this will be equal to what? No, I think I missed out a 0, you know. Too many zeros. So this will be 0. I think this is where I reduce it to 1 0.
0.01255. Yes.
Ah, there you go. See there? All right. Now, for persons who are not convinced about this 10 times the volume, I'm going to work it out the long way. Same reasoning, but I'm going to work it out the long way. All right. So this is what we know. Remember, you are working from known to unknown. This is what we know. We know that 0.001255 moles are in 25 cm cube. We want to find out how much is in 250 cm cube. So that is what is being asked. All right. Again, math trick, cross multiply. All right. And then you end up with moles is equal to, see the cross multiplication there? All right. 0.001255 times 250 divided by 25. Punch it in a calculator and tell me if you get the same thing. See there? Last one, and then we're finished, ladies. The last one says, find the mass of sodium hydroxide dissolved in 250. All right. So to find the mass is equal to the number of moles times the molar mass, which is the MR. Now, you know MR is just that it's not using that sense. All right. What we know for MR, we know the relative molecular mass. Now, the relative molecular mass, the values is the same as the molar mass. So molar mass is just saying what is the mass of 1 mole of this substance. So we're going to go into it this week, don't worry. What is the mass of 1 mole of the substance? And so you calculate it just like your relative molecular mass. How do we calculate relative molecular mass again? Look at what they give you. They give you relative atomic mass. What are we going to do with these? So all you're doing, you're just adding the mass numbers for all the atoms and how many of the atoms. So in this case, sodium hydroxide is made up of sodium and the oxygen as well as hydrogen. Based on the formula, there are no subscripts, and so they're all one. So one sodium atom, one oxygen, and one hydrogen. So what are the values for each atom? So this is 23 plus 16 plus, no, let me write it in order. 23 plus 1 plus 16. And you end up with 40. So this is equal to number of moles. Remember, we found number of moles right here. So we have 0.01255 times 40, 0.052.
02, miss.
And that's grams because they asked us for mass. And that's it. This is how you would have solved it, ladies. And that would have been your question 1.